Right triangle trigonometric application problems, right? Example 1. Consider the figure to answer the questions. Determine length to the nearest hundredth and the angles to the nearest tenth of unit. So we are given a figure here. Determine length AC. So AC is this length which you need to find. Find the angle ACB, that means ACB, that angle, and determine the length BF. So B to F is this length, is what you need to find. Okay. Now, so let's try to see here. We can find in different ways. So what I will do is I'll do one way, and you can try to figure out how to find in a different way. Now, first is finding AC. You note that the triangle ABC is a right triangle, right? So we can use Pythagorean Theorem, right? And therefore, AC will be AC square is equals to AB square plus BC square. And so AC will be square root of 20 square plus 10 square, right? So for using Pythagorean Theorem, let me write down the equation here for you, right? We say AC square equals to AB square plus BC square, right? And therefore AC is equals to square root of AB is 20, right? So we say 20 square plus 10 square, which is 20 square is 400, right? And this is 100, so it becomes square root of 500. So that is what you get. And if you use a calculator, you can use a calculator, right, to calculate square root of 500, and we get 22.360. Now they say determine the length to the nearest hundredth, right? So we can write this as 22.36, correct? So that is the side AC for us. Now what you can do is you can find BD. So I'll leave that as a question for you. So I'm writing your questions in a different ink. So I'll write for you, find BD, right? So you can say determine AC, and for you, determine BD, right? So BD will be in a similar way, right? You can use 15 square plus 10 square to find BD, correct? So that will be an exercise for you to do. And the second question is, find the angle ACB. So angle ACB. Now to find this angle, we can use trigonometric ratio. So we know two sides here. One is, if you want to find angle ACB, so that is this angle, right? Angle ACB. Now 20 is opposite and 10 is adjacent. Adjacent between the 90 degrees and the angle is 10. So when you are given opposite and adjacent, then which trigonometric ratio can you use? Of course, tan, right? So the angle C, I can write tan of C, I can write tan of C is equal to 20 over 10, right? Which is 2, right? And from here, I can write angle C is equals to tan inverse of 2. Is it okay? So we'll use calculator, second function, tan inverse, and within bracket, we'll write 2 equal to, and we get 63.43. 63.43 when rounded to 10th will give me 63.4 degrees, correct? So that's the angle ACB, right? So as an exercise, I'll give you to find the angle DBC, okay? That is angle DBC, okay? You should do that on your own, okay? Now let's do part C here. Yeah, I have skipped some part of it because I will be giving that as an exercise to you, right? And as I'm giving you, right? So determine length BF. That means B to F is this distance. So we need to find that distance. Now how can you find it? Well, by now you know the angles also, right? So if you know the angles, you can find this side also using angles. Second, we can use similar triangles, right? You see the big triangle ABC and triangle EFC, they are similar. They have 90 degrees, right? And that angle ACB is common to them. Therefore, triangle ABC and triangle EFC are similar. When the triangles are similar, then the ratio of their sides is same, right? Is a constant. So we will use that property to figure out what is BF, okay? So we can say AB over BF. So AB over BF, let me see, first I should write, so AB is big triangle, so AB over, I should take BC here, right? So big triangle. So if you see from this angle, opposite to this is AB in the big triangle and the base is BC. So that is the big triangle. And we are considering the small triangle, which is C, E and F, right? So we can say that this is equals to EF over FC, right? So EF is corresponding to AB, so we write EF over FC, right? FC. Now AB over BC is 2 over 10, 20 over 10, which is 2, correct? So we can write this as 20 over 10 is equals to EF over 10 minus BF. Is it okay? Because what is FC? FC is this. Is it okay? So FC is 10 minus BF. So I'll write EF as FC as 10 minus BF. Does it make sense to you? Yeah. And now we'll cross multiply and we'll write 10 minus BF is actually equal to EF. So we get one equation here, right? We did cross. So 20 over 10 is actually equal to 2, right? So 2 times 10 minus BF, it should be 2 times 10 minus BF is equal to EF. Is that okay? So that is one equation which we get. Now we can find, now we have two variables here. One is EF and the other one is BF. To find two variables, we need two equations, and fortunately we can do so. Let's consider the triangle BDC and BEF. These two are also similar triangles. Is that okay? So we'll write here. If we consider these two triangles, correct? So we have DC over BC is equal to small triangle EF over BF. Is it okay? Now DC over BC is 15 over 10 equals to EF over BF, right? 15 over 10 is 1.5. So this is equals to 1.5. Is that okay? So from here we get EF is equal to 1.5 times BF. Is that okay? So EF is 1.5 times BF. So we get EF equals to 1.5 times BF. So we got two equations for EF. One, let me push this page a bit forward. Okay, so one EF is 1.5 BF. The other one EF is 2 times this, which is like 20 minus 2 BF equals to EF, right? So let's say this is our equation 1 and this is our equation 2. With these two equations, we can find BF and EF, both of them. We need to find BF in this case, right? So let's write EF as 1.5 and solve for BF. Okay, so let me do it here. So we say 20 minus 2BF, 20 minus 2BF is equals to 1.5 BF. It's like solving two equations, right? Eliminating EF. So we substituted the value of EF from 2 in 1, correct? So we got this. So we'll bring this to the other side and we say 20 minus 2BF. So when we take it on this side, we get 20 equals to 2 plus 1.5. Let me write 3.5 BF. Is it okay? So BF is equals to 20 divided by 3.5. Is that okay? Okay, which is 20 divided by 3.5, which is 5.71. Now 5.71, which is 5.71. Now since length to nearest 100, that is our nearest 100 length, right? And so we get our value of B to F also in meters, correct? So that is our answer. So we get, determine the length of this. We say, well, the length is 5.71 meters. Okay. So I would like you to do or to find the side length BF using primary trigonometric ratios. So that is an exercise for you. Okay. So what you can do is, instead of doing, I applied the method of similar triangles, finding these ratios. Now ratios, you know, this ratio is tan theta, right? So tan of theta is 15 over 10, correct? So you know these angles. So these angles and these two angles will help you find EF and BF, these two equations. So as an exercise, try to do this part use trig ratios, right, to calculate EF, let us say EF. So that is homework for you to do. Okay, so this is a very interesting problem because here we have all the concepts together. One, we are dealing with right angles using Pythagorean theorem to find hypotenuse. Then we utilized our knowledge of similar triangles to find the missing sides. And third, I left as an exercise for you to find the missing length using trigonometric ratios. Okay, I hope you'll enjoy it. Thank you.